Okay, so we saw in the last episode, we looked at how to move our ship around. Now, it wasn't very pretty and it wasn't very fluid because we had to press the right key every time we wanted him to move even a single step. And it was a bit clunky. And if you haven't already done what I did in that lecture, then I suggest you do it and you experience how he moves when we implement it like that. Now, if you don't want to do spaceships, obviously you can have whatever kind of a theme you want for it. That's totally fine. But we're looking at spaceships. So how can we improve on the movement system, make it a bit more fluid? Well, we want to strive for realism. So in reality, when an object moves, it moves with a certain amount of velocity. So when we consider a car, when you push your foot down on the accelerator, it will start to speed up. So every second that you push your foot down on an accelerator, your car's speed will go up. And when you take your foot off the accelerator, your car doesn't immediately stop moving. Your car will carry on coasting, is what we say. So we have two competing forces. We have acceleration and we have deceleration. The brake decelerates you, the accelerator accelerates you. And you have a constant velocity. And that is only slightly reduced by the fact that your foot's not on the accelerator. And that's due to sort of friction with the pavement and things like that. But fundamentally, unless you're pressing the brake, you're not going to be slowing down. And unless you're pressing the accelerator, you're not going to be speeding up. So that's what we want to have in our game. We want to have a constant velocity. And this is what it's going to look like once we've programmed it. So here we have a couple of variables at the top. And if you remember those from the last lecture, they are properties of a sprite. They're things that the sprite has. So at the moment, if we think of this like a car, the car is at rest. The car is not moving anywhere. And we can see its velocity, which is another word for speed over time. So the speed it moves at a particular moment in time is 0. So the car is not moving. In this case, the spaceship's not moving. Now, when I put my finger on the accelerator, which is in this case the right button, I'm going to press it a little bit and then I'm going to take it off. So I've done that. Now I've forgotten to press the play button, so let me just undo that a second. So I press the play button, so that's my mistake. So we're going to press the accelerator. So let's push the accelerator down a bit. Now I've taken my finger off the right mouse button. Sorry, I've taken my finger off the arrow key, and we can see he's moving constantly. Now let's press stop, and I'm going to push harder on the accelerator for longer. So let me reset this back to 0. So the way you change these values is by double-clicking them, and you get a little slider option there. So double-click, double-click. I'll show you this when I actually come to programming it, but I want to show you for now the goal, which is this this script. So I'm going to press harder and longer now, and he zooms forward, and my velocity goes up higher. I'm pressing the left button now, and we can see he decelerates. So let's accelerate a bit faster, 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 slower, slower, slower. Now we're going into reverse. Now we're going to accelerate faster forwards, and then going backwards. And you can see here, I've also implemented this for the right axis. So he's now constantly moving at whatever velocity he's moving at. And then I press the keys to alter that velocity. So this looks much more natural. And once you've programmed it, you're going to feel that it feels a lot more natural as well. It's much more fluid. Okay, so let's find out how we're going to do that. Let's go back to the solution we had at the end of the last project. So here's the solution we had at the last project. We had him moving, actually we don't have it here, but we've got him moving when we press the keys, and we were using move X steps to do it. Okay, and we were changing his X and his Y coordinate as well. So the first thing we're going to need to do is we're going to need to record his velocity. So a car's speedometer tells you how fast it's going, and as long as you're not pressing the brake, that speedometer is not going to go down, and as long as you're not pressing the accelerator, the speedometer is not going to go up. So hopefully everyone understands then the idea of velocity and the fact that it is only going to be changed when you intervene, either by pressing one of the pedals. So let's make a variable. We're going to call it velocity in the x direction. So this is forwards and backwards. So when I press my foot down on the accelerator, that velocity is going to go up, which is going to result in the car starting to move. So now we need what we're going to call a game loop. And a game loop is the sort of logic to follow. Now, if I was going to program a car, I would have to start off by saying, well, whatever its velocity is, whatever the speedometer says, well, that's how far it's going to move every second in time, or every hour in time. So if your speed is 30 miles an hour, you're going to move 30 miles every hour. So if it helps, think of this as like a speedometer. So how are we going to move this according to the speedometer? Well, motion sounds like a good bet, and we saw in the last example how change x by and then a certain amount lets us move him. So if I change this to, for example, 1, now that means when I press the go button, the logic for my program says whatever's happening all the time, move forward by 1 on the x. So let's run that and see what happens. Brilliant. Now, that's not quite what we want. We don't want to always be moving forwards, because your car is not always moving forwards if your speedometer here is at 0. Our speedometer is at 0 here. Let's change it to 1, change it to 5, something like that. Yeah. Once this goes higher, the speedometer is much higher, so the car should be moving forwards much faster. So let's adjust this, and we saw last time how we could adjust this to use variables. So let's drag that one out. Now you'll notice the shape here is rounded, and the rounded shape means that it fits into a rounded button here. So we can't, for example, stick this on here. It doesn't make sense. This is a value, and this value here is going to be whatever that is there. So it's 0 at the moment. So let's stick that in there. So our programming logic now says when the green arrow is pressed, always change x by the contents of this box. Okay? This variable here. And it's 0 at the moment. So let's press the go button and see what happens. So it's 0, so it says change x by 0, change x by 0, change x by 0, change x by 0. This loops around constantly changing it by 0. Now, let's see if we increase the speedometer. There, I've increased it, it starts going forwards. And I can actually set it to a negative number. So if I want to set this to a negative number, I can actually just drag this here, put in a negative 10 here, for example, or negative 3, let's say. So let's set it to negative 2, and he starts going backwards. Set it to 2, he should start going forwards. Starts going forwards, starts going backwards. So hopefully everyone's happy with that. That's the speed of the car, the speedometer. And the logic of the program says, whatever your speedometer is currently at, adjust your movement to that. Okay, adjust your x by that speedometer rating. So let's just clear up the workspace a little bit. And we can remove these as well. So now we want to be able to change the speedometer. So the speedometer we want to be at 0 to start with. There we go. Now, what's the equivalent for pressing the accelerator? Well, it's going to make our spaceship move forwards, so let's make it the right arrow key. That makes sense. So we'll drag in the right arrow key and the left arrow key. Now, in our previous example, we were changing the x here, and that means this event move right is triggered, when they press the accelerator down, and they move right one step. Now, that's not what your accelerator does. It doesn't make your car go forwards. Your accelerator increases your speed, and your speed is what makes your car go forwards. So let's get our heads around that again. Your accelerator doesn't make your car go forwards. Your accelerator in your car increases your speed, and your speed is what makes you go forwards. So there's your speed. So we need to increase the speed, because this is the world, effectively. This is the logic of our program. It's saying move forwards by your speed. And now we need the accelerator to change the speed. So if you have questions about this, you can email me. My email address is in the lecture notes and the announcements on MyDundee. So we're going to change the speed here, velocity x, the speed. So let's change the speed by 1 whenever the right arrow key is pressed. And we will change it to -1 whenever the left arrow key is pressed. So we need to press the green button here so we can start the program. And you'll see how it's highlighted. That means that it's running. It's now constantly saying, what's the speed? What's the speed? What's the speed? Whatever the speed is, change my x by it. Speed's always 0 because the car is at rest at the moment. Yeah. So let's try pressing down the right arrow key. So that's me effectively pushing down on the accelerator. Now it's changed to 1. It's now changed to 2. It's going faster. Changed to 3, 4, going faster still. Now let's press down on the brake, and you see that affects my velocity. It's now -4. It now goes backwards. So forwards, backwards, forwards, backwards, forwards, backwards. And this is much more fluid movement now. It's more fluid movement now because we have this sort of logic step here, which is saying whatever the velocity is, update yourself based on it. Now, if you're following along and doing this, you should find that you're getting this kind of nice fluid action now. It should be much nicer than it previously was. Now we need to duplicate this for y. So we've not only got forwards and backwards. Yep. Not only do we have our speed, we also have our up and down, our vertical. Now, if you're a sort of piloting guy, you know that was like pitch and yaw, I imagine. Pitch and yaw, up and down. But we'll not worry about that. So let's make the variable. We'll call it velocity y. Now let's drag velocity y here. Now if we want to show it, we just actually, so it's appeared directly on top of it. That's why. So once you create a variable, as long as it's ticked here, it'll appear in the window here. And if it doesn't appear, check to see whether there's something under it, obscuring it, or over the top of it rather. So here we can see now, not only do we have the speed in the number of units per loop, we've got the speed up and down the way. So speed left and right, and speed up and down. Brilliant. So if the logic of our world is to change your position based on your speed, yep, if you're going fast, you're going forward much faster. If you're going backwards, you're going backwards much faster. So let's go up and down as well. So we'll just duplicate this, except that we're doing the y-axis in this case. So motion, change the y-axis. We'll change the y-axis by the y velocity. So now we've added in the logic that says whatever your speed is, up and down the way, we'll change your position based on that. And this loops around at 10 times a second or something, or 5 times a second. It's probably about 10 times a second. And it moves you based on your speed. So this is what we would call the sort of the physics of the game. It's saying, well, whatever your velocity is, change your position based on it. And this is what we would call the user interface. This is the bit where the user starts changing the properties of the object. Now, if I'm going too slowly in these lectures, make sure you send me an email and I will try and speed things up a bit because I don't want to sort of bore you guys to death. So in this case, we now want to handle when they press the up arrow. When they press the up arrow, we want to increase their y velocity. So think of it as an accelerator being pushed down in the up direction. We want to increase their speedometer, make them go faster up the way. There's a speedometer, it's going to go up when they press the up arrow. We will duplicate that for going down the way, and in this case we're going to change it to -1. Brilliant, so let's see how that works. So now you'll notice we can move in both the X and the Y at the same time. We can actually get the ship moving in a wee circle, and that's because they're independent of one another. We are changing the X and the Y velocity based on whether or not we've pressed the keys. Yeah, whether our foot's on the accelerator. And in this case, we have two accelerators. We've got an accelerator on the right-hand side, accelerator vertically. Okay, so once you've implemented this, you should find you've got a much more fluid movement. And you should start to understand a bit more about these variables. They're values that are held and that we're going to change the location of the ship based on. So they start out at 0, we change them, and they're just a record. Variables are a record. So I'll probably do a PowerPoint on this, and we'll go into some of the theory about exactly what these variables are. But if you can use them like this, then you can start to understand why they exist. Okay, so next time we might look at detecting when we've bumped into something. So we could have an asteroid, for example, that you've got to avoid. And we could have the asteroid move around and potentially bounce off the walls and things like that. So get a bit closer to a game. We might even look at including a score or something like that.